Hello, welcome back to Algebra 1. Here we're going to tackle the concept of polynomial long division. Now, long division in algebra gives a lot of students problems. So what we're going to do is eliminate any frustration that you have by taking this entire lesson. We're just going to really work one real problem. But we're going to talk about it so much that you're probably going to be bored at the end. But the point of it is I want you to really understand what we're doing just with this one problem. And then we have like 4 or 5 more lessons after this where we're going to crank through a ton of different examples. So if you don't 100% get it at the end of this lesson, just watch this lesson a few times and then continue on into the following examples. And we will pick it up through practice. But for now, I want you to really concentrate on this as many times as you need in order to get the concept down. All right. So what we're going to do before we do anything with algebra is we're going to review regular long division because the algebra long division really follows very similarly. So what if you had the problem 155 divided by 2? Remember, this is what we call long division, right? So let's go ahead and work through this problem, and we're going to draw some conclusions, and then we're going to do another problem after this that's going to involve algebra, and you'll see how it follows the exact same process. So what you do here is you first attempt to see if 2 will go into the first digit, 1, and 2 will not divide into 1. So then you expand your search and say, will 2 go into 15? How many times will 2 go into 15? The answer is 7 times because 2 times 7 is 14. So what you do is you put a 7 and you put it over the 5 because what you're doing is you're saying that it goes 7 times into the 15. Then the next step is you take 7 times 2, which is 14, and write that down directly underneath what you were just working with, and you subtract them. All right, now 15 minus 14 is 1, so you just put a 1 here. And then after you've done the subtraction, you look for the next digit if there is one. In this case, there's a 5, and you drag him down. So I always draw a little arrow to remind myself that I'm dragging the 5 down from up above, and so now I have another 15 down below. Then I see, does 2 divide evenly into 15? Of course it does. We just did that a minute ago. 2 times 7 is 14. So we write the number 7 up above in the next digit space here because 2 times 7 is 14. Then we do the multiplication. This 7 times 2 is what we just said, 14, so we write it down. And then we subtract them, and then the answer is 1. 15 minus 14 is 1. So there we go. Now, if there were another digit here, like if this were 1,557, then we would drag another digit down and continue the process. But since there are no digits here to pull down, and since 2 cannot go into 1, then we're basically finished. There are no additional digits to pull, and there's no additional division to do. So the answer is 77. That's how many times 2 will go into 155. 77 whole times. But we have this remainder down here. We have 1 left over, effectively. So the way that we write this answer typically down, there's a couple of different ways to write it, but when you first start learning division, the way that you write it is the answer to this problem is 77 with a remainder of 1. And what this tells you is it goes 77 whole times. That's how many times it divides in, but there's a leftover 1. In other words, there's a kind of a fractional part left over that you can't divide another time, so it's just kind of left hanging out there. When you first learn division, you write the answers like this, 77 with a remainder of 1. But then, as you move along, you can write the answers in a different way. So what you do is you say it goes 77 whole times, but this remainder of 1, it's just how many pieces are left over that I can't divide evenly into. But instead of just leaving it there and saying there's 1 left over, we can write it as a fraction. And the way you write it as a fraction is 1 and you divide it by what you're dividing by. So in this case, it's 1/2, 1 divided by 2. So you would say that the answer is 77 plus 1/2, or 77 and 1/2 is typically how you write the mixed numbers, remember that. And of course, you know 1/2 is 0.5, so it's 77.5. So if you take this number in the calculator, 155, in a calculator and divide by 2, you're not going to see this. You're not going to see remainder 1. You're going to see 77.5. So when you do the long division, you always end up with the remainder there. So you can write it as a whole number plus a remainder. But you can also write it as a fractional part, which is the whole amount of division that happens plus the remainder that you get divided by what you've divided by. In this case, it's 2, so it becomes 1/2, which you can convert to a decimal, 77.5. All right, that is stuff we've learned long time ago in math, and we're reviewing it because it's going to help us with their algebraic division in a minute. Before we get to that, I want to show you how to check our work. Because the reason I'm doing it with this problem first is because when we do our polynomial long division, you'll get the answer, and then you're going to have to check the answer a lot. And so I'm going to show you how to check it with this basic problem here. How would you check to see if this answer is correct, or this one, or this one? I mean, they're all the same, really, but how would you check this one here, the 77 remainder 1? Well, what we're saying is that 2 divides into this number 77 whole times. So in order to check it, the way you would do is you would say 77 times 2, right? Because the opposite of division is multiplication. What do you get when you do that? 77 times 2, if you do that multiplication, you will get 154. Okay? But it doesn't go 77 whole times. It goes 77 whole times, but a remainder of 1. That means that we have to take the 154 that we got and add the remainder back in. And what do we get? 155. So what you should get is you should arrive back, and I'll put a check here, you should arrive back at the number underneath here, because when you do division, you get this as an answer with the remainder. When you multiply, you should get that number, add the remainder back in, and you should arrive back at what you started with in your original problem. So this checks out for this particular problem. You take your answer, do the multiplication, add the remainder back in. Okay? Or you can check it another way. It's actually not any different, but I'll express it for you like this. Notice we said 77 remainder 1 is the answer, but we can also write it as 77 and 1/2. You express the fractional part as the remainder divided by what your divisor is here. Okay? So what you can do is you can check it as saying, and I'll put parentheses here, 77 and 1/2 times 2. Basically, we're saying that the answer to the problem is 77 and 1/2. So if we multiply by 2, what do we get? If you pull out a calculator or do that long multiplication, you'll just see that the answer is 155. So however you check it is fine. If you just multiply and add the remainder, or if you use the fractional form and just do the straight multiplication, you should arrive at exactly the same number that you had underneath this division sign. So that is a review of regular division. Now what we're going to do now is scoot our paper up here, and we're going to do a polynomial long division problem, and you're going to see now with that as a reference that the polynomial long division really operates exactly the same way. It just looks a little more confusing. So what we have, let's say, is we have 8x squared plus 6x plus 3, and we put our division symbol here. And on the outside, we're dividing by something complicated, looking for x plus 1. Now, a lot of students look at a problem like this and they immediately get terrified because this problem doesn't have any real resemblance to this one. This one looks familiar and nice and you know what to do, but this one down here doesn't. Let me break down that barrier for you and show you that it's really not a big deal. The thing that you need to know whenever you're doing these kinds of problems is you need to kind of only look at one thing at a time. In other words, don't look at everything back here. You're going to get to this stuff later. And even with this term out in front, don't really look at the plus 1 right now. You're really only going to be looking at the leading term, which is 4x. So what you want to do is see how many times will 4x, forget about the 1, how many times will 4x go into this? Now that may be a confusing thing for you to think about too, but really when you go back to our original problem, what were you doing up here? You were trying to figure out how many times does 2 go into 15. So mentally what you do is you say, well, 2 times 3 is 6. That's not enough. 2 times, 2 times 6 is 12. Okay, that's not enough. And then you keep going. 2 times 7 is 14. Bingo, that's pretty darn close, because if you go one higher, 2 times 8, that's 16. That's too high. That's not going to work. So really you're doing multiplication in your head. So when you're doing this, don't think of it as necessarily how many times will 4 go into this. Think about 4x times something up here that I have to write down is going to equal 8x squared. 4x times what is going to give me 8x squared? And there's only one thing that's going to work. We need a 2 here because 4 times 2 is 8, and we need an x here because x times x is going to give me the x squared. So convince yourself, forget about the 1 here, that's irrelevant. The 4x times this 2x does indeed give me 8x squared, because that gives you the 8, that gives you the x squared. Make sure that you understand that that is the case. Okay, good. So finally you've hopefully gotten to that point. Now let's go back up here and review what our next step was. Once we put the 7 here and realized that 2 times 7 is 14, what we did, and that gave us as close as we can get to 15, right? Then what we did next is we multiplied them, got 14, wrote it down, and subtracted. That's what we did next. So we're going to do exactly the same in this problem. Right? Once we've written this down, we have to multiply. Now here's the deal. When you do the multiplication, you multiply times this entire term, which means 2x times 4x, and you write it down here as 8x squared. But you also have the 2x times the 1, because there's a plus sign here. So you're multiplying by this entire thing. So you have plus 2x, because 2x times 1 is that. And then we subtract. So you see it's really doing exactly the same thing we did when we worked with numbers. Okay? So you go term by term. 8x squared minus this is 0, so I don't have to write that down. 6x minus 2x, 6 minus 2 is 4, so the answer is 4x. All right. So you see we've kind of done the problem. Let me scoot up here. We've done this problem down here all the way up until the point where we did the subtraction and we wrote the 1 down here. Now what was the next step? We look at the next digit and we drag it down to make another number and attempt to divide again and do the same process over again. So that's where we're at here. We take and we look at this and say, we did the subtraction, and now we look, now we don't have another digit to look at, but we have another term here. We have a plus 3. So really what we have to do is we're going to drag this down just as if it were another digit, right? And put the plus 3 like this. That's what's down below. And then we continue the process again. But again, whenever we try to see if this will go into this, we again only look at the leading term, 4x. How many times does it go into 4x? We ignore the 1, we ignore the 3. We're only looking at the first term dividing into the first term. How many times does it go? Well, it only goes one time because it's the identical thing. Positive one time. So we have a positive sign there and we put a 1 right there because it only goes one time. Once we have this number up in the top, we continue the process. 1 times this whole term, 4x plus 1, is going to give us 4x plus 1. We do that multiplication, draw another line, subtract. And then we do the subtraction. 4x minus 4x is 0, so I don't have to write that down. 3 minus positive 1, 3 minus 1 is 2. So I'll put the 2 here. So you see now we've done everything twice. We have done the subtraction, we have it down here. We look for another digit to drag down, but there is none. And 4x cannot go into 2, obviously, because I can't take and multiply this by anything reasonable anyway to give me the number 2. So when you've exhausted everything to pull down and you've done the subtraction, this is effectively your remainder. What you have found is the answer is 2x plus 1. That's how many times it goes in, how many whole times it goes in. Much like in this problem, the numbers on the top where it went in 77 whole times with a remainder of 1. In this particular problem, it went 2x plus 1 whole times with a remainder of 2. So I'll just write this down and say, this is the remainder. And the problem is basically done. So how do you write the answer? That's really the million-dollar question. All right, so how do you write the answer? So let's go over here and write the answer. Now, in the previous problem with numbers, we basically said that the answer was going to be written as this number here, remainder of 1. And we can write them in these other ways, including, let's see, where do we have it? As a fraction right here. We said we had the whole part plus this divided by this. This was the fractional part, which made 77.5. When we do these polynomial problems, that is how we're going to write all of our answers. We're not going to write down remainders. We're not going to say 2x plus 1 r2, remainder 2. We're not going to do that. The way we're going to write it down is we're going to say the answer is 2x plus 1. Right? Instead of putting r2, remainder 2, what we're going to do is write down plus a fractional part, where the fractional part is 2 divided by this, which is what we had divided by. So it's going to be 2 divided by 4x plus 1. So that's a fraction. It's a fractional part. So this is the final answer. This is what you would circle on your test. And I know it looks complicated and it looks cumbersome, but you need to kind of think about it and realize that this part of the answer is really kind of the whole part. This is how many whole times the thing divides into there. And then this thing is really the decimal or the fractional part. Because it is a fraction. And it is exactly no different than the answer that we got up here. When we wrote it down like this, we wrote it as 77 whole times plus 1/2, which is this guy right here. And that's how we arrive at this mixed number right here. But in algebra, things look a little more complicated because we have letters and numbers. So we have the whole part plus this divided by this thing we're dividing by out here, which is what we call the fractional part. So that's the answer. So the question is, how do we check something like this? Because I told you that you would be checking almost all of your work, and you are going to be checking almost all of your work. You need to know how to check your work. So basically, when you think about it, what we said is when you take this and you divide it by this, the answer is this long expression, 2x plus 1 plus 2 over 4x plus 1. It's a giant expression. So how do you think you would check it? Well, there's a couple of ways you could do it. Remember the concept of a remainder. What we could do is we could take the whole part and we can multiply by this, and then we can add the remainder. Remember the remainder was just down here as the number 2. So we're going to follow exactly the same process. There's a couple of ways you can check it. So what we could do is we could say 4x plus 1 times 2x plus 1. All that we're doing here is multiplying these things together. This times this. That's how many times we said it went in there. Let's do that multiplication right now. So we have the first terms multiplied, 8x squared. Okay, and then we have the inside terms, positive 2x. And then we have the outside terms, positive 4x. And then we have the last terms, 1 times 1 gives us 1. Okay, and then we can obviously simplify this. It's 8x squared. This is going to be 2 plus 4 is 6x plus 1. Now that was just taking these and multiplying them together, right? But we still had a remainder we need to add in, just like we did it for the numerical problem. So when you take this as 8x squared plus 6x plus 1, and then add the remainder of 2, what you get is 8x squared plus 6x plus 3, which is exactly what we started with in our problem. So when we take our answer up here, multiply it by this, and then add the remainder that we got, at the end, we got exactly what we should, which is under here. This is exactly the same thing as we did up here. We took 77, right here, 77, multiplied it by 2. This is what we got. We added our remainder, and what we got was what was underneath this division symbol. So we know that the answer is correct. Now, let's do it the other way, which it's really not anything different, but it just, it looks a little different sometimes. Let's do a second check. Let's do another way. This is the remainder, and we said that we can write it as a fractional part. So the answer, the full-blown answer, is 2x plus 1 plus this guy right here. So if we take this entire answer, which is the full-blown answer that we get, and we multiply it by this here, we should arrive at what we get here. We don't need to add any remainder anymore because it's already wrapped up here in the fractional part. So what do? We say 4x, let's see what happens, 4x plus 1, and then we're going to multiply by this really big expression, 2x plus 1 plus 2 over 4x plus 1, like this. So what's going to happen here? We have this guy, whoops, sorry about that. We have this guy multiplied by this term, but then we have this guy also multiplied by this fractional term over here. So let's go ahead and multiply everything out, or at least write everything down. So the way you could write this is 4x plus 1 times 2x plus 1 plus 4x plus 1 times that fractional part, 2 over 4x plus 1. You see, all I've done is I've taken this 4x plus 1, I've multiplied it by this term, and then I've multiplied it by the fractional part. We'll do this later, but notice what's happening here. We have a 4x plus 1 on the top canceling with the 4x plus 1 on the bottom. So if you look carefully, what are we actually going to be doing here at the end of the day? We're going to take the 4x plus 1, we're going to multiply by 2x plus 1. That's what we did right here, and that's going to give us this. And then since these cancel, we're just going to be adding 2. Which is exactly what we did here. So you can already see that these two lines of reasoning lead to exactly the same thing. 8x squared plus 6x plus 3. That's a check. That means that if we take the full-blown answer, which includes our fractional part here, multiply it by what's out in front, we're always going to get what's on the inside because we're going to see this nice cancellation. And effectively what's going to happen is we're going to be doing this multiplication, and because of this cancellation here, we're going to be adding our remainder back in. So whether or not you want to do it this way or if you want to do it manually, you're going to get the same answer. This is exactly the same thing as what we did before when we took the whole and fractional part and multiplied, and we got the answer that was under there. So this was a pretty long lesson, I'll give you that, and I do understand that it is a complicated topic that gives students a lot of problems. The thing that you need to realize is that the main thing you need to realize is whenever you're doing this, you always just look at the first term dividing into the first term. You get that, then you multiply, write it down, subtract, drag your next digit down, do the same process again and again until you can't do it anymore, and then you have your whole thing, and then you write this as a fractional part in your answer there. So watch this lesson a few times if you need to. Watch the whole thing. Watch the beginning. Do that simple problem with numbers first to refresh your memory on how to do division, and then do this one yourself. You should be able to replicate everything down to the exact correct answer, including checking yourself. And then, when you feel like you kind of get it a little bit, follow me on to the next lesson. We're going to crank through a ton of these examples. This will not be difficult for you, and they will not take this long to do either, because we're going to crank through them and you're going to get a lot of practice. So follow me on there now, and we'll continue getting your skills ready to go with polynomial long division.